This paper consists of the automation of data preparation tasks, which reduces the time taken to prepare the data for mining, and the automation of data mining tasks. In this paper is present an integrated approach built on Karma for information integration and data mining. The approach combines the steps in data preparation and data mining into a single integrated process and maintains detailed metadata about the resources. The work reported in this paper has a big importance on the data scientist world, because with this information, the process of data preparation and data mining is going to be optimized and streamlined. And with the use of the approach built on Karma, the data scientist is going to reduce the investment of time during the data preparation, the data mining, and the data integration, which are processes that requires a big quantity of time.
Okay, so here we have the following paper from IEEE in 2014, and it basically aims to develop a technique that can integrate data from multiple sources with a more upper quality pattern recognition process, and that is using mapping in large databases. This paper has a great level of significance because it tackles down some of the most common issues nowadays in big data, and that is data integration with huge loads of data coming from different sources. It is also very original because it proposes an algorithm for mining multiple databases. Now, the methods are well described on the paper itself, but mapping basically happens when the whole relationship between the sources and the unified view of them. The user issues queries. The system carries out the tasks of extracting data from the sources and reassembling them into one answer, thus obtaining data integration. Now, preparation of warehouses is very important throughout this process because we're talking on a multi-branch organization, and integrity constraints really make the query processing process really difficult, so that's something we can improve further.
My paper is research and application on the model power and parallel data integration. The subject of this is explain a proposed parallel data integration model based on NEO, a system that solves redundancy inconsistent problem in the data integration process with conventional tools. The significance of this is that this document solve problems with the level of efficiency in the integration with big data. It helps us to solve the inconsistencies during the integration, and especially the aspect that we have. In fact, we have a lot of conclusion doing efficiency analysis between the proposed algorithms and with Hadoop. I think that the difficulty of this model is very hard because we have a lot of tools like Neo, Hadoop MapReduce, and also we have Spark. So we are manipulating big data. So big data and the inconsistency with big data is very difficult to deal with when we are doing integration, especially when with the conventional tool that is Hadoop. Um, and yeah, I think that the most difficult thing aquí is like check the consistency. And I think that the lesson that the author gives us is that we can use a lot of tools to implement the data integration.
Hello, I'm going to present the paper Advantage of Integration in Big Data, Feature Generation in Multi-Relational Databases for Imbalanced Learning. Well, what does this paper state? First of all, they present us a problem. They say that the majority of data mining and machine learning algorithms work with a single table in a database, right? While the potential knowledge is stored in data spread across many tables, it could be also other databases and other data sources. What does this cause? It could cause the miss of several important features, avoid generating attributes, also class overlapping, and maybe leakage. How do they solve this? Well, also they say that in order to get all the benefits from data mining algorithms, the relevant attributes of the data must be accumulated in a single table. So they propose this algorithm called GARP, which stands for Generating Attributes with Rolled Paths. What does this algorithm do? Well, it automatically generates attributes from all data sources and instructs them in a single table. They introduce the concept of rolled paths. The algorithm provides an automated process to generate features rather than endure them in big data domains. It also avoids including duplicated information on rolled paths by performing stepwise joins and generates attributes containing useful information from the past missed by existing techniques, what I just mentioned.